Hi, Kieran again. Just about to release 1.7.4 of DevKit. It's been another week, so I thought I'd get you guys another video with some of the new features. So here we go. First of all, I'd like to show off something that looks pretty good, pretty cool. It's the live update memory feature, which is useful for looking at algorithms and if you put the frequency down, it's you can see what's going on in a program quite easily, and it's quite impressive to look at. So if I just make sure everything's set up here and give it a go, let's see. There we are. I'll get onto that later. So I hit F5. I can't remember if I showed this. No, I think I invented it for this demo. So here's a sort of randomly updating display here. Just adding some random values. And if we open memory view, just like usual, as you might have guessed from the name, it's going to show live updates. So, not making much sense there, but hopefully you can see the value in that. If we slow it right down, you can kind of see it updating in sync there. This update is limited to a few frames per second. I think it checks 2 to 5 times a second, which should be good enough, I think, for most purposes. But yeah, it's pretty good. For that DRM demo someone posted, it was kind of good. If you slow it right down, you could see it decrypting the message, or rather displaying the message. So that was a nice potential use there. Okay, let's see what else we've got. So a few editor features. There's this right-click menu, missing basic functionality that got lost when we changed the editor control. Find and replace, Control F, or the menu option there. Kind of overdue. Implemented from scratch though. Again, the editor control, the new one rather, didn't really support it, so it works as you'd expect. There's a stack view, which is kind of, it probably doesn't deserve its whole pane to itself. It's nicer if you sort of drag it to the side here. One of the items on the to-do list is, of course, window management, layout, that kind of thing. The memory view and stack will probably be somewhere down here. That's quite high on the priority list now, along with some kind of relocatable code and output builder. So as you might imagine, you've got it looks at stack pointer onwards unless stack pointer is 0, in which case it displays nothing, which is the default when the program starts. Let me step into that. So there's nothing there, but then something gets pushed and it gets displayed. You've got the value here, and then some character representation. It uses the same engine as the memory view, and then some symbol information, which I'll get onto in a moment. And as you can see, kind of just displays a stack. Right, symbol information. In fact, I'll skip over for now. Something that probably hasn't gone unnoticed by many is the release of the DCPU toolchain. And just to try out the plugin API here, put it through its paces, I figured I'd give a crack at integrating with it. So as you may have seen, there's a .c file here, which is basically demonstrates that. What I wanted to do was take a quick couple of minutes to show you the code behind this plugin. I wanted to demonstrate that it's quite easy, in fact, to integrate new languages into DevKit. So here we have this new DCPU toolchain plugin. I think it's DCPU 16 toolchain is the correct name. So you've got your plugin class, which you implement. It's got some basic fields. In the load method you set stuff up, which might be registering a new memory device, something to handle display, hardware device which handles interrupts, that kind of thing, or a file type provider through the build manager, and that's what we're doing here. So you have to create a file type provider class, give it some information like what's the type of the file, extensions, can you create a new one, is it textual rather than binary, is there default file content if you go create new, and then these are the important ones really. Editor control strategy defines how it should appear in the app, and here we've got a code editor strategy, and that uses the built-in editor, but you get to define some highlighting rules. So I've put this together very quickly to hopefully catch most C keywords and so on. And then the last one's the important one, create file scope, which is used for compilation and also debug symbol generation. Create file scope creates a new instance of file scope, which derives from iSource file scope. And what that does, it represents, if you imagine there's a code graph in memory which has the solution, beneath that all the projects, and beneath that for each file there's a file scope which holds identifier information, labels, macros, all that kind of thing, everything that's contained within the file. An easy way of representing everything in terms of code. So how it works, in this particular case, we pass in a file name, which is the C file, and then almost immediately invoke the compiler. This isn't necessarily the only way to do it, but it's what came to me first. So we grab, there's the compilers in here, just DTCC and Bootstrap. So we basically execute that, pass in our file name and output to a temporary file. Grab standard error and standard output to try and read any errors back in a nice format. We read the contents of Bootstrap plus the text in the file. Check for errors roughly here. We process any errors from standard output, which just has a bit of string manipulation and adds it in a compatible format. And that's almost it. The file scope object has some methods you have to implement, many of which could be ignored if you're doing something quite simple. This code and the code for the example basic and binary resource plugin are available on GitHub, so it should go some way to helping people along. So the compile method, as you might expect, is quite important. When you get to various passes, things have to be done to progress it. But if you've got a language compiler which outputs assembler, then things get a bit easier. What we're doing here is just checking for errors and outputting them if there's anything outstanding, and then creating a new inner scope here. And what that means is we're offloading most of the work to the built-in assembler. Effectively, we're going to use the built-in assembler but feed it assembly that came out of the C compiler. So this is roughly where we do that. We read the compiled assembly output of DCPU, the DTCC, and do some basic processing. There's these uline directives that are created in it, which have line number information. We use that to build a bit of a map of the source, and then pass it to this create custom assembly scope, which is a built-in service type object. Anyway, what that does basically means we can integrate with C in DevKit. Now there are a few problems. I'm going to call it sort of an initial alpha version really of integration with the toolchain. We've got the nice highlighting. It does indeed compile if I hit F6 there. You've got breakpoints, the symbol information I'll talk about in a moment. It builds fine, it runs almost fine. I think with the release there are a few bugs with the toolchain, a few incompatibilities. It will run, I'll show you in fact, and it does work in a interoperable way. So there's this main here. It exposes methods that are in C with cfunc underscore and then the method name. So I'll find that here. So the underscore actual is another part. There's a sort of a pre-method bit of code that it adds, I think, for setting up the stack. I just thought I'd ignore that for the purposes of testing here. So if we run that, it will basically flag up a bit of an error, and this is something I've raised with the toolchain guys, and I'm sure they're on top of it. It could, of course, be an incompatibility, something this end, but let's take a look. So it overwrites some memory. I think it's something to do with an invalid stack frame, and it seems that they've now got a hold of that, as I say. But if we ignore those errors and just continue, we can basically see that it does what it says. It sets the first memory location to A, and if I set a breakpoint, we'll just run that again. Oh, there we are. So the single step is still stepping. Oh, that was unlucky. It's still stepping. Of course, single instructions rather than lines of code. So you see there I had to hit F10 quite a few number of times to get through all those instructions. Single stepping through source won't be a problem to add, but while it's still in the early stages I've left that off. So assigning this value to screen, I think it does these calculations on the stack, so that again takes quite a few, but if I keep going, there, finally. Obviously optimization is high on those guys' priority list, but it works, which is great. It integrates. We can jump to and from code. We've got some level of debugging and highlighting there. So it's a good start. So moving on, I should say there's this Bootstrap assembly file, which is kind of built in, as you saw here. It's built into the code that's assembled every time, so it doesn't work particularly well for multi-file things. But then again, it doesn't work particularly well at the moment anyway. But proof of concept. The Bootstrap file has some required symbols which aren't in the C file. If you wanted to, you can still step through the C code, but if it does use any of these Bootstrap methods, then it would go straight to disassembly. So if you happen to add the Bootstrap file straight to your project, then you can step through those instructions when they come up, which is what you saw there. In fact, let's take a really quick look at that. If we jump there, I guess if I go to the return line, yeah, so you see it goes to this internal method. Okay, so global symbols, which you've probably just seen. Every file now has this drop down which indicates symbol information. You've got sort of labels which are major labels, and then in a lighter green there's minor labels or local labels. So you've got this locate found method in here, for example. You can select it to jump to it. And there's a dot boundary. In fact, I don't think these are local labels. Some syntax used by DCPU. Let's have a look. Main. So yep, it differentiates between data labels, code labels, macros, definitions, and you can fly around quite nicely. It ties up with the current cursor position. And there's a global list here as well, so you can jump to exactly what you need. It'll open files and switch them and all that kind of thing. Which obviously speeds up development, working with larger files and that kind of thing. Yep, so that's some of the major features. There's lots of other bits and pieces, bug fixes, and other requests which we've implemented on the disassembler. Let's take a quick look. There's this new option, stop disassembly when an invalid instruction is found, and that's the default behavior. So it will start disassembling at the base address and stop when it hits something bad. And the reason for that was there might be an invalid opcode, or rather, if you try and translate it into a DAT, it could be that you come in halfway through another opcode, or the next word starts a 2-word opcode, which then throws everything else out. Basically, anything after a bad opcode you can't really trust. But you can optionally disable that, and then obviously it'll keep going to the end. There's a warning there because if it has a live update mode, so if something's changing memory, it'll have to re-disassemble each time. It can go a bit slowly, but there are some circumstances where you might want to use that. You can get this new version hopefully by the time you're watching this video. If you're interested in the DCPU toolchain compiler stuff, that will obviously continue to be updated and be a bit more usable and workable, but there's scope there for playing around and looking at the source code to the plugin, which is on GitHub, as I said. Get in touch with any questions or problems, and I think that's about it, so I'll go and release.